Hey everyone, Math 100. We are working on section 1.6 today, exponents and the order of operations. So to start things off, take a look at this expression. I'd like you to evaluate this or find the value of it. Now if you're not sure how to handle this, don't worry about it, just do the best you can. Pause the video, find an answer for that, and we will revisit this later. So today we're starting off with exponents. Now mathematicians love shorthand. Multiplication is just shorthand for repeated addition. So if I want to take 5 3s and add them all together, well, I can just multiply 5 times 3. We've got another shorthand for multiplication, and that is exponents. So let's say you want to take some 2's and multiply them together. Just put it in exponent form, 2 to the 4th power. What this means is, 2 being the base, 2 is the number we're going to repeatedly multiply. And 4 tells us how many times the 2 appears. So we've got 4 2's. We're going to multiply them together. Now note, if you see a number with no exponent, you can just assume that it's an exponent of 1. So 5 is the same as 5 to the 1st power. It's kind of the same thing like in algebra, when you might write down an x, or you can write down 1x. It means the same thing. Now we're going to go back and forth between expanded notation and exponent notation. So we're going to convert this to exponent notation. So we're multiplying 7's together. That means 7 is the base. So that's the big number on the bottom. And let's see how many times the 7 appears. 1, 2, 3, 4, 5, 6. So we have 6 7's being multiplied. So that means that is 7 to the 6th power. Your turn number 1. Please write that in exponent form. Okay, so the base is 9. We've got 9's being multiplied, so that's going to be 9 to some power. And we'll count up the 9's. 6, 7, 8, 9, 10. 10 9's being multiplied, so that is 9 to the 10th power. Now we'll do the reverse. I'm going to take 4 to the 5th and evaluate it, see what that equals. We got 4 times 4 times 4 times 4 times 4. So 5 4s. So we got 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1,028. 24. I almost forgot what powers are 2 there. 10. Or 1,024 for that one. Your turn number 2. Let's multiply and evaluate 3 to the 4th power. Third to the 4th power. So our base is 3. And we're multiplying 4 times. Or we have 4 3's being multiplied. So 3 times 3 is 9, times 3 is 27, times 3 is 81. 3 to the 4th is 81. Next up, we're going to examine some powers of 10. Take a look at this table. Notice that as we go down the table, the exponent keeps decreasing by 1. And you can see the value of this expression on the right. And so what I'd like everybody to do is take a look at this pattern and figure out what 10 to the 0 is going to equal. Alright, so as we go down the table, notice that the number of zeros keeps decreasing by 1. We got 5 zeros here, 4, 3, 2, 1. That means down here we won't have any zeros left. So 10 to the 0 is 1. A lot of people we'll guess 0 here. That's probably the single most common guess. But it's not going to be 0 because that doesn't follow a pattern because we have a 1 in each one of these numbers. We just have 1 fewer zeros. So we lose that 0 and we have just 1. And that is by definition, that's the definition of a 0 exponent. It doesn't just work for 10. Any number, say that a for any number, to the 0 power equals 1 by definition. All right, your turn number 3. Let's find the value of those 3 expressions. So the first one, 2 to the 6th plus 3 squared. 2 to the 6th is going to give us a C. We have 6 2's being multiplied. So we got 2, 4, 8, 16, 32, 64. And 3 squared is 9. Add them together, we get 73. Next one, 8 to the first power, that's just the same as 8 without any exponent. 6 squared, 36. Add them together, we get 44. And finally C, 9 to the 0 power, that is equal to 1. 4 to the third, we got 4 times 4 is 16, times 4 is 64. Add them together, you get 65. Now, how did I know to do the exponents first and do the addition last? Well, that's the order of operations agreement. So order of operations tells us a way of evaluating expressions that's going to give everyone who evaluates the expression the same answer. So we don't get different answers. Imagine if that happened in your bank account. And we need an agreement so that everyone gets the same answer each time. So we're going to start with parentheses. So within a larger expression, anything within parentheses, we're going to do order of operations inside the parentheses first. Then we'll move on to exponents. And then we do multiplication, division on the same level, working left to right. So whatever appears on the left first, that's what we do first. If there's a division on the left, we're going to do that first. If there's multiplication on the left, we'll do that first. We're working left to right, do all the multiplication divisions. And then the last thing we're ever going to do in one of these expressions, outside the parentheses that is add or subtract. So addition and subtraction is always going to be last. So first example, we do order of operations on 9 times 7 plus 12. So the order of operations agreement tells us to do parentheses and exponents first. We don't have any of those, so we're going to go right on to multiplication and division. All right, we only have one of those, so we'll start here and do 9 times 7 is 63. And then on each step, whatever you don't work on, write it down. Don't skip writing down. We want everything written down on every step. And then finally, addition and subtraction is last, so we'll do that now and get 75. That brings us to your turn number 4. Your turn number 4, you're going to do 4 times 6 plus 18. You're got our multiplication first, 4 times 6, 24. Bring down the 18. Do addition last. You get 42. All right, next one. 8 times 5 minus 28 divided by 4. Multiplication division first, left to right. So we're going to do this left multiplication first and get 40. All right, now a lot of people like to work left to right. Biggest mistake I see on this one is then doing the subtraction next. Remember, addition and subtraction are always last. So we're going to do this division first. So that gives us 40 minus 28 divided by 4 is 7. All right, now we're down to subtraction. Do the subtraction last to get 33. Your turn, number 5. Start on the left. 4 times 8, that's 32. All right, so second step, we're going to complete the multiplication division. So we've got division here, 18 divided by 3 is 6. So that gives us 32 plus 6. Finally add them together to get 38. Next up, (64) divided by 2 to the 4th plus 10. So for the first time now, we actually have an exponent in the expression, so we're going to do that first. 64 divided by 2 to the 4th, we've got 2, 4, 8, 16. All right, next up is the multiplication division stage. So we're going to do 64 divided by 16. It gives us 4. Now we're down to just addition. So we can add those together. You get 14. Your turn, number 6. So exponent first. 5 squared is 25. Then we can do 50 divided by 25, or multiplication division is next. Divide those to get 2. Subtraction is last. And 1 is the answer. Next example, we got 9 squared minus 2 times 19 minus 5. All right, now we've got some parentheses. So we're going to start there. And inside parentheses, we just do order of operations. Ignore everything else. We're going to work inside here. Well, we only have one operation, so this will be 14 there. So that gives us 9 squared minus 2 times 14. So after parentheses comes exponents. So we're going to do 9 squared to get 81. 81 minus 2 times 14. All right, next up, multiplication division. We got one multiplication here, so we'll do that next. 81 minus 28. Subtract those. And we get 53. Your turn, number 7. All right, first up is parentheses. 12 minus 7 gives us 5. Next up is the exponent. 8 squared is 64. Then the multiplication. So that's 64 minus 20. Finally subtract to get 44. All right, next up, we've got multiplication, addition, and parentheses. We'll do parentheses first. 18 minus 6 is 12. And over here, we'll do this multiplication. So 12 times 8, that's 96. And finally add them together to go 108. That brings us to your turn number 8. So 10 times 7 minus 20 minus 2. Okay, so start with the parentheses. 20 minus 2 is 18. Next up, multiplication. 70 minus 18, and then finally subtract to get 52. Next example, got a bunch of exponents on this one. Five squared plus 8 squared divided by 4 squared. So we can start off by doing all the exponents at once. 5 squared is 25. 8 squared, 64. 4 squared is 16. All right, now next up we have multiplication or division. The multiplication division step. Got this division here, so that gives us 25 plus 4. Finally add them together to get 29. All right, your turn, number 9. So 6 squared, that is 36. 9 squared is 81. And 3 squared is 9. Next up, multiplication division. 81 divided by 9 is 9. So we got 36 plus 9. Finally add. We get 45. Next example. This one's just full of multiplication and division. So it's especially important in this case to work left to right. So we're going to start off with this leftmost division, 75 divided by 25, that is 3. We got 3 times 8 divided by 6. Now again working left to right, we're going to do this multiplication here first, 24. And then finally divide to get 4. And that brings us to your turn, number 10. All multiplication division, so work left to right. 100 divided by 20, that is 5. And left to right again, 5 times 6, that gives us 30. And then the final division, 30 divided by 3 is 10. All right, next up, now we've got a more complex expression with a whole bunch of different things in. We got exponents, parentheses, multiplication, pretty much everything. All right, we're going to start inside these parentheses. Let's do this first. 8 minus 5 gives us 3. Write down everything else exactly as it is. And now we're going to do the exponents. So we have 3 to the third and 15 to the 0. So 3 to the third is 27. 15 to the 0 power is 1. All right, now we've got multiplication. So let's do this next. We're going to do 12 times 11 is 132. Now we're doing addition, subtraction. We're going to work left to right. So we're going to do this subtraction first. 132 minus 27 gives us 105. And then finally add on the 1 to get 106. Your turn, number 11. All right, we have parentheses here, start there. Now minus 7 is 2, so we have 2 squared. All right, exponents next. 3 to the 0, that is a 1. 2 squared is 4. All right, now we have multiplication, division. Start on the left here, 1 times 9 is 9. Then we'll do the division. 4 divided by 2 is 2. And finally subtract to get 7. All right, now that brings us back to the warm-up. So let's evaluate that now that we've gone through and seen all these order of operation problems. So starting within the parentheses, 5 minus 3 gives us 2, so we're going to have 2 squared down on the end. Now we'll do the exponents. So 4 is for both of those. All right, now we've got multiplication and division. There's only one of those right here in the middle. 8 divided by 4. And that is 2. All right, now we've got 3 plus 2 here on the left. We've got all addition, subtraction. So we work on the left. 3 plus 2 is 5. So you got 5 minus 4. And then finally subtract to get 1. All right, last thing, we've got an application problem now. The world record in the marathon, achieved by a person whose name I'm going to have a really hard time pronouncing, on September 16th, 2018. And this marathon was completed 2 hours, 1 minute, and 39 seconds. Hard to believe anybody could do it that fast. All right, let's figure out how many seconds this is. And we're going to use the fact that there are 3,600 seconds in 1 hour and 60 seconds in 1 minute. All right, so we've got 2 hours. And to figure out how many minutes that is, we're going to multiply by 3,600. All right, 1 minute, and there's 60 seconds in a minute, so 1 times 60, and then finally 39 seconds. All right, let's figure out how many seconds this is. 2 times 3,600, that is 7,200. 1 times 60 is 60, and we got 39. All right, so we're going to have to add all these together. Let's see. 7,200 plus 60, that gives us 7,260 plus 39. And then finally add these together and we get 7,299. Ran the marathon in 7,299 seconds. Order of operations ends up being one of the most important topics in mathematics because we use it in so many different places. So make sure, go practice this as much as you need to really get it down. And what I recommend doing is once you go through one of these problems and get an answer, it's okay to take a calculator, type in the expression and see what you get and check your work that way. That way you can find any mistakes and go back and rework them.